Hello, and welcome to this presentation of Incredible Design Innovations with Autodesk Inventor. My name is Brian Verboort, and I'm a Solutions Engineer with M2 Technologies. Thank you for taking the time to watch this presentation. Let's briefly go over the agenda. First, we will take a look at some of the design challenges you might face every day in your design and manufacturing environments. And we'll see examples of just some of the benefits users of Autodesk products enjoy to help them solve some of these problems. In addition, we'll take a look at some of the business benefits you'll realize by adopting Autodesk solutions. With regards to design management, it's frequently a challenge to track changes throughout the life cycle of a project. In addition, change and release management of designs can also be difficult. And design requirements are becoming more and more complex. As customers' expectations rise, these requirements are becoming more difficult to meet. And in an effort to meet these design requirements, our design solutions are having to become more and more creative. And once design requirements are met, it can be increasingly more difficult to have an easy and appropriate level of communication and collaboration with customers in manufacturing. Today, we'll use this clamping fixture as our example. This fixture has been designed to position and hold a sheet metal assembly for spot welding. We will focus in on this particular clamping station and go through the process of a design change that has been requested to improve performance. Alright, so let's start out by launching Vault Explorer application. We're being asked to authenticate and log in to the Secure Vault environment. And once logged in and loaded, you'll see the Vault environment looks much like Outlook. The fact that you can browse and navigate in this upper frame, traverse your design structure that you might currently have. We can also do things like be notified if you've got pending work that needs to be done. In this case, an engineering change order has been started and initiated. And because this is, I'm responsible for this, I've been assigned this engineering change order, I'm responsible for it, it shows up on my work list. Take a closer look at that change order. We'll see it's in an open state. We'll also note that there are a few things here identified as being the work to be done. We can take a look at the associated files in a situation like this, and there happens to be a markup that's been attached in this case. We'll take a closer look at that in the window. So once the markup loads in, you'll see that the red line in markup has been accomplished. We're being told that we want to minimize some of the mass of this upper clamping plate without compromising structure or strength, in addition to review the pneumatic cylinder here that's actually applying the clamping force of 300 newtons. So having been informed with that information, let's take a little closer look at the status of this current change order. You can see it's been created and transitioned into the open state. Since we're going to be doing the work on this, I'm going to go ahead and just transition it by responding and submitting it to the next work state, or to the next state, which is work. So we have now a work state, and we can track who did what when at this particular state on this change order. Now that we've achieved that, we'll take a look a little bit closer at the design model itself that we're being asked to modify. We'll do a search here in the Vault environment to find the model, the subassembly that's being changed. So we'll do a search for files, and we're going to just do a search by file name. It's the same name as the change, as the red line of markup is. So we'll just type in what we know there and then add that to the list of items being searched for. You'll see we get a substantial number of files found here. We can refine the search a little bit further by adding in IAM as the file extension and then running the search again. We can then identify that this appears to be the correct assembly, and we can go even a little further, taking this assembly and going to the folder in Vault where that assembly exists. So we'll find that it's here, and we can take a quick preview, look at it, just to identify it as the correct subassembly. We're going to start out by actually doing a copy design on this assembly, this particular design. You'll see that this item is listed at the top here. It's a work in progress. This is the entire assembly. So as we scroll down this list a little ways, we'll also see that there is a clamping mechanism itself they're going to want. So I'll expand that. You'll find that there's the assembly, and then there's also the plate. So we'll include those three items, and we want to make a copy to a specific location. I'll go ahead and use the assembly folder here. We'll create a new folder called redesign. And we'll use that folder for our location for the new copy. You notice the file name that's shown here. We have automatic file naming capabilities. We can assign numbering schemes in these environments. You'll see that there is a 200 series numbering scheme that's being applied for this particular product line. And once we've determined that that's the appropriate file name numbering system, then we'll just initiate the copy design itself. You'll see that the resulting design copy is shown there. We'll go ahead and we'll close that. And then we can expand our assembly environment and see the documents that are associated with this particular redesign, including the assembly itself. Let's take the items that are on this list and then add them to the change order. So we're going to add it to an existing change order, which has a specific number. There's the change order. Now these items have been added to that change order. I could find one of them, or any of them for this matter, and I could say ask it what change order it's used on, and then go to the change order itself. You'll see the items are then listed here and the preview for the particular revision A. In this case, we're pretty happy with what we've done so far. I'm just going to right click and open this document for editing. Prompted for checkout, I'll submit yes, and it takes us over to Inventor, launches the assembly up in the Inventor environment. We'll update the assembly, and we'll be asked to take the routed systems, check the routed systems out of the environment. In this case, we have several different models here. I'm going to switch over to the Vault view so that we can see that we have checked out a couple of the different subassemblies in the process of initiating this work. At this point, I'll go back to the model environment, and we're going to create a model environment. And we're going to create a new sketch. We use the origin folder here. Just spin it back the correct way here. And we're going to want to do a little bit of work on the force effect environment. In this case, we're going to be creating a new force effect model. We're going to put it in the same location as the assemblies in the redesign folder. We're going to be acquiring the information needed to satisfy ourselves that the model is effective. This environment, I'll right click and I'll change the background. I'll select the file, and in this case we've got a layout that we can use in this environment. It's simply an image of the assembly. It can be either taken with a digital camera or otherwise. In this case, we're going to want to zoom up so we can define some of the locations for the statics. And I want to create an element that describes that location. In this case, we want to go to 190 millimeters. And that scales the entire assembly. We can actually zoom up a little bit more and also describe an element that represents the center of that particular pivot. Now we'll zoom back a bit, get a little bit longer range look at this assembly, and one more element that describes the back plane. We'll go with 455 on the length on that one. And then let's go ahead and add in a constraint to fix this. In addition, we'll add a constraint that will lock in this pivot point in position, making it welded. If I now go to the kinematic environment, I can do a kinematic drag, which then shows us the description of the motion in action. You'll also notice that we have a situation where we're in a state of equilibrium with this system. If I go back to the static environment, you'll notice that we're not in equilibrium, we're in an indeterminate state because we haven't applied any loads or forces yet for the work we're about to do. I'll zoom up just a tiny bit here. We're going to add a few forces. So in this case, it'll be a force that's well known. It'll be the 300 newtons that we acquired. Also note that we've got an issue with the units of measure. So we'll resolve that currently by just going to the document settings, changing the force units to newtons, and then making a modification to 300 instead of 3,000 kilonewtons. So there's our single force. We also have another force that's undetermined. It's an unknown force. That force is going to be applied here at some unknown angle. So you can see that the force is represented. If we were to move or drag this to a known angle or direction, you'll see that that force is then going to update and change the force that's required. If we move this further, if we move this a little further, pivoting it to the connection point, which is roughly 81 degrees, or I happen to know it's 82 degrees, then we'll discover that we're getting roughly 1,000 newtons required. So I'm going to zoom back out just a little bit here to incorporate the entire design. Then I can make a report of the statistics that are here. So you can see the force effect model is built out in report. The values, inputs, forces, the results from the in the form of reaction forces, etc., are all played out here well. Go ahead and just close this up. And then the report itself, notice we're in a state of equilibrium, and save it on the way out. In this case, I'll now then finish the 2D sketch. It takes us back to the 3D environment. So let's go to work on the plate itself. So I'll use a part priority filtering to open that plate in its own environment. With this environment, we want to do is we're going to start out by making some edits using the direct editing tools. This is going to allow us to make some changes to this model, just giving us a larger boundary that we need, and I can go with 20 millimeters. I can fix that at a distance. We don't have this checked out to us, so we're going to be prompted to check the document out. I'll go ahead and make another edit here as well, just dragging out an unknown distance. I'll go with 45. Now that we've prepared this by resizing it a bit, let's go to work in the shape generator environment. You'll see when I transition to the shape generator environment, It's really an analysis environment we're talking about, but it's reversed. We flipped that on it. It's on its head. So what we'll do is we'll start out by placing a pin constraint describing the status of this mechanism. We'll also apply a bearing constraint. This is where that cylinder is going to connect to this plate. We'll also do a bearing constraint. We'll select the faces for the bearing constraint, and we'll describe the vector, and then add the forces of the 1000. In addition to that, we'll add a frictionless constraint on the surface here where the jack screw attaches. Beyond that, we want to have the ability to preserve regions, meaning that we'd like to keep material in specific areas. So I can define keep out areas essentially by picking a cylindrical surface, and then a planar surface also describes a box or rectangular body shape keep out area, all of which can be modified. Now that that's been accomplished, let's talk about generating the shape itself. Go ahead and run the study. In this case, the keep-outs will be preserved. There will be no material removed from them, and the larger boundary will give the system some freedom to add material as required in those areas that we don't have clearance problems. So this is a resulting shape that we see overlaid onto our current plate, using the current plate as our boundary. We have an original mass of 2.5. We've got a new mass of 1 and a mass reduction of 58. Let's take a little look at this and make some changes to the shape generator settings. I'm going to be a little more aggressive, and I'd like to see this reduced by 75% mass. In addition to that, I can do things like change the material. You see the model is a mild steel now. I can define it as something else. In this case, we'll go ahead and just use a steel alloy. And between those two changes, with the more aggressive material removal for weight reduction and the change in material, we'll now see that we've got something that needs updating. And let's generate that shape again. So there's a more aggressive attack on this, and the results have been updated. We're 2.5 kilograms. We're almost a half a kilogram on new mass with 70% weight reduction. At this point, I think we're pretty good. What we'd like to do is then promote this shape into the current part file, or we can export out as an STL document. I'll select OK here to include that shape. You'll see it listed here as part of the boundary. Next thing we want to do is we're going to change the way that this looks. We're just going to go to a wireframe and then create a new sketch on this top face. This will allow us just to use some of the standard tools that Inventor is well versed with. Your basic typical Inventor user is well versed with utilizing. Fix some boundaries here just to trim off some of the shape. And then here we'll go ahead and we'll build out a bit of a connection here. Same situation here. We'll make a box shape that's closed boundary. And we can do things like add in parallelism. For example, I can make this parallel to that. I can make this parallel to that. I could also add in constraints of any type when it comes to like general dimensions, so I can control the distance from here to here, and then the distance maybe from here to here. Another thing we might want to do is go ahead and just do some filleting. Since we know this is going to be a conventionally machined part, we'll add in some fillets here at the sketch level, which will help us describe the geometry a little bit better with a little less trouble. And just a couple nudges here to get things a little bit more located with the size and shape we're looking for. I'll right click and we'll finish that 2D sketch now. And then just using a traditional extrude function, we'll remove all the material that we don't want. This will be a cut operation, and we'll be through all in both directions symmetrically. Now that we've got that accomplished, I'll go ahead and we'll turn visibility off on the model itself and come back and change our visibility to shaded with edges. At this point, I'll do a little additional filleting with some of the sharp edges that are left from the process that we had. Again, a conventionally machined part, and we'll go with a 5mm fillet radius. In addition to that, we can use some filleting tools known as a rule fillet. And then let's create a quick drawing using a standard template to place a couple views on our drawing. In this case, we'll switch to the vault environment. We'll go ahead and we'll check in these two documents. Notice that the analysis that's been run with the component part is still going in as well. Close that part. We can see that the changes that we made here are now more appropriate. If I initiate an update in this case, we'll be asked to check out the particular subassembly that was just modified. And again, just reviewing the state of objects that have been vaulted and the modifications that have been made. One last thing that we'd like to do here is to change the cylinder by using a component replacement. So I can come in and find a purchase part that might meet the requirement better than the original one. We might flip it to use a different one now. And that's going to be changing our bill of materials significantly. And you'll see it listed here as a new component. We'll zoom out. We'll make the saves that are required for the assembly. And we'll take this assembly and simply check it back into the vault environment. Back in vault, we can then see that some of the components, for example, the part update is there, the assembly is updated. Let's check the status here and progress this through the process So we're now submitting this to the check state, and if I'm responsible for checking, a notification will be given for the person that's responsible for that approval. I'll respond again by approving it. Again, a notification occurs. Change order's been modified, and we'll do one more. We'll spawn and approve it. So all the files on our change order are now updated and reflecting the new revision information.